Hello and welcome back. All right, now we're going to build the class of the neural of this convolutional network, and this is exactly the same class and exactly the same model that we built before. So I'm not going to go ahead and explain it because it's just going to be a waste of time since I already explained it in the previous section, uh, in the previous video when we're doing the basic CNN. So go ahead and refer to that video if you don't understand what's happening here. So let me just run it. Okay, there we go. We have our CNN class defined, and then we need to define our model by creating an instance of this class. So we define model, and then this is the GPU to CPU switching. So we just move our model to GPU if we do have a GPU. Then we define our loss, which is the cross entropy loss, and our optimizer, which is the stochastic gradient descent. And you can, if you want, okay, if you go ahead and type torch dot optimizers dot, and then you go ahead and press tab, you get all of these loss functions. So you can use any loss function that you wish. So for example, you can use Adam, you can use RMS prop, you can use anything that you wish. All right, for now on I'm just gonna go ahead and use this stochastic gradient descent. So let me run this. Okay, it's gonna take a while since it's moving the model to the GPU, so just wait for it. Okay, it's done. Now let's understand what's really happening here. So this is it's not always a good idea to run your convolutional networks on the data without knowing what's really happening. So let's dive deep into what's happening. Now, first of all, I'm going to show you. Okay, this is obvious. There's nothing new here. We're just taking our inputs and labels in the train loader. Now I'm using this because I just want one batch to be shown. Okay, one iteration. Sorry. So I'm running all of this only one time. You realize that I have iteration equals to 0, and when this whole iteration is done, okay, that means when one batch is loaded, then the iteration will be incremented, and then when it's going to check back for this condition, then it's going to see iteration equals to 1. It's just going to break from that loop. So we just end up printing the results for one batch only. So first of all, we're just going to take our inputs and labels and wrap them up in variables. Then we provide GPU to CPU switching, and then go ahead and print the results. So for one iteration, this is what happens. We're going to print the input shape as well as the labels shape. Then we're going to calculate the output. Okay, and we don't care now what the output is because we're just looking at the shapes. And then we're going to see what this output shape looks like. And then we're going to take the predicted the prediction of the network. So we're going to run torch.max output 1, and then we're going to print the shape, and then we're also going to predict the tensor, and then we're going to take the correct predictions. So we're going to add the predicted with the labels, and then we're going to sum them up and then print them out. Then next we're going to do the same thing again, however using the dot data. And why I did this, because I want to show you that it doesn't matter if you put labels.data or labels, as well as predicted the outputs.data or just the output. So it doesn't really matter. I told you before, output and output.data is the same thing. Okay, now it is of course suggested that you put output.data, but it doesn't really matter, and I'm going to show you, I'm going to prove to you that it doesn't matter. So let me run this and let's see the results. Okay, so it's still running. Oh, sorry, we got an error. Okay, sorry. So I forgot this underscore no data here. So this is the output, the final output shape. Okay, so for one iteration, this is what happens. You have your input shape. First of all, the number of your batches. You have 100 batches, and in each batch you have the number of channels, which is 1 because it's a grayscale image. Number of rows 28, number of columns 28. So 28 by 28 image, one channel, you have 100 batches. So you have 100 of these images here. Labels.shape is just 100 because for each image you have label. Now the output shape, after you run the network, this is the output shape that you got. 100 times 10. So 100 because you have 100 images for the batch. Now in each image there's 10 columns, and each of these 10 columns specify the softmax outputs. Okay, so basically you'd end up just taking the maximum of this to get your answer. Now the predicted shape is 100. So the predicted shape is just taking the torch.max along the row dimension. So for each row you take the maximum, then you end up with 100. That's why. So predicted tensor, this is how the predicted tensor looks like. Okay, so this is, you're just taking the maximum across each row, storing it here, the maximum across the second row, the maximum across the third row, and until 100. Now you have your correct predictions equals to 10. So you have 10 correct predictions, and as you can see when we run the again this code, when we run it with the dot data. Okay, the first one was the dot data, and now now we're not going to specify the dot data, so again you get the same answer. So it doesn't really matter if you put dot data or you don't put dot data. Okay, it's going to give you exactly the same exact answer. That means here we got 10 correct predictions. Now realize that your network is not trained yet, right? We haven't trained our network yet. Okay, so that's how we can visualize what's happening here. So thank you very much, and I'll see you next time.